Bye. Zev, would you like to chime in here now?
Sure. Yeah, well, there are a couple terms that have been mentioned so far that I'd like to describe and expand on. There's been myco-remediation and myco-restoration, and I'd like to add to that myco-forestry. And of course, myco just means fungus, so you can attach it to any word. You could say, you know, myco-president or myco-parties, and we could have everything attached to fungus in one way or another. But myco-remediation, myco-restoration, and myco-forestry, I would almost describe those as a short, medium, and long-term ecological approach. And let me explain what I mean. Myco-remediation is using fungi to break down actual acute toxic situations that we have with, like Doris was saying, oil spills. They're fungi that can break down nerve gas, that's deposits of nerve gas that are left from Vietnam War in these hidden areas in the Southwest. Mushrooms are in this unique enzymatic situation because they've evolved in the role over the millions of years of being kind of the primary decomposers in ecosystems. And so they have a unique class of enzymes that break down even rock sometimes, but certainly organic matter in forests that nothing else can break down and make absorbable for plants and then for animals. So because they're in that unique enzymatic role, they use the same enzymes that they use to break down rocks and lignin and cellulose and wood in plants. The same enzymes break down all kinds of petrochemical based compounds that we've created in our industrial disaster. And
now that photograph up there is that turkey tail?
That good guess. It's it's a different polypore. It's maitake, or hen of the woods, or Graphola frondosa. Yeah. It's one of the choicest edibles around here. It grows usually on dead or dying oak trees at the base.
Right.
It's a polypore, which means that it has pores on the undersurface rather than gills. So that's one key classification point. It's one of the first things you look at when attempting to ID a mushroom is whether it has gills or teeth or pores on the bottom.
Gotcha.
Yeah, that would be a great one to show. So there's myco-remediation, which is the breakdown of acute toxic reservoirs of chemicals. There's myco-restoration, which is using fungi to restore damaged ecosystems that are damaged by development or logging or other generally human activities, but sometimes natural things like fires and landslides and earthquakes. That's myco-restoration. And then what I would say is kind of the longest term use of fungi is myco-forestry, which is using fungi in ecosystems in which we've basically adopted a forest agriculture approach. And forest agriculture is probably related to many of the other guests that Robert has had on the show. It's forest agriculture is emulating the natural ecosystems that we have in such a way as to produce more food and medicine, and do it in a way that is actually regenerative. And what I mean by that is kind of a step beyond sustainable. So sustainability means just diminishing our impact on the earth enough that we can maybe keep doing it for a while, whereas regenerative land use is actually recognizing that humans have a positive role that we can play in the biosphere, that we're actually active participants in ecosystems. And so mycoforestry is an example of regenerative land use, and it can actually be a part of a cyclical forest agriculture system where mushrooms are used to break down the residue of sustainable logging or other forestry activities, and then jumpstart the cycle back again and tighten the cycle so that less nutrients are lost to erosion and to runoff. And the whole time we can actually be producing economically valuable, edible, and medicinal mushrooms.
Right. That is the key. And if anybody out there would like to change their fields and would like to get into the main field of restoration of our planet, that is this is just one aspect of how we can restore the planet. If we want to look at the amount of funds right now out there doing restoration. We would be really astonished on how much is being done, but obviously there's a lot more to do. We're just at the beginning of this process. We're not in the middle, and we're definitely not near the end. So if somebody wants to protect themselves against not having a job or not doing something productive for the planet, this is an area that I would encourage you to look seriously at.
Yeah.
I'd like to comment on that. I was just through some link arrived on the Obama-Biden official website the other day, and there's this whole talk of green collar economy, and they've made some pretty serious and committal statements about devoting tens of billions of dollars to so-called green collar industry over the next 10 years to both jumpstart the economy and also to put our culture in a much more regenerative pose. And this kind of work is something that could easily be funded by the money that is being diverted. In terms of energy efficiency, you can do all kinds of things in cities to reduce air conditioning need by planting forest gardens around parking lots, even to reduce the heat island effect, things like that. So there's a huge money. But I think the biggest point of leverage on all this is to find activities that are both funded from outside and create funding from inside. And what I mean by inside is they actually produce products, physical products, and there's a huge worldwide and growing market for medicinal mushrooms in particular right now. There you go. Thank you. Yeah.
Let's put up that.
I was going to mention that.
Yeah, and I would like. Go ahead.
I want to say, add on one thing. I got an email the other day about. It was an article about mushrooms. They're finding it's a type of polypore, and they're showing that it can probably be used for fuel instead of all the fuels that are being, the corn and the crops. Yeah. That whole situation is getting really dire. But they found a certain, it's in Europe, a certain type of polypore that they're finding very promising.
Interesting.
In producing biofuels. Yeah.
Well, going along with that, and there's a fungus that lives in the gut of termites. Because you mentioned how of course, the fungi are the only kingdom of organisms on the planet that have the enzymes to break down all these plant materials. So termites actually rely on a microscopic unicellular fungus that lives in their stomachs for the enzymes. And so people have extracted that enzyme and are actually using it to break down grasses into sugars, which can be fermented into ethanol.
Wow. Now there's something to think about right there, because biofuels we've had on a couple of times on this program, and we insist that biofuels are a way to go, and we also insist that corn is not the right way to go.
Right.
Yes, we need to look at algae, we need to look at switchgrass, we need to look at hog waste, North Carolina. Take a look at that to try and produce something that will run our vehicles, because we are 100% importing everything that runs with tires in this state, and it has to stop. We cannot. It's not sustainable, and we need to do something that is. Well, great. We want to just mention in the background we have a reishi mushroom. You want to go on
Doris,
that one?
did you want to, or do you want me to
go
jump
ahead,
on that
go
one?
ahead.
All right, we can tag team. This is such a wonderful, wonderful ally to humans, and that one looks like the Ganoderma lucidum, which grows in China, but there's one that's native here that grows on dead hemlocks, interestingly. And so reishi is a hugely investigated fungi right now for the different types of polysaccharide beta-glucans in it, which are this class of compounds that have all kinds of properties, including anti-tumor, anti-cancer, anti-HIV, anti-herpes, and general immune-stimulating properties. And there's a native one that grows on dying hemlocks, and of course, a lot of us are aware that we're having a lot of dying hemlocks right now with the woolly adelgid.
Yeah, we had Patrick Battle on talking about how we need to bring in the predators.
The beetles. So we want to save them, but if we can't, For the ones, for the trees, the individual trees that we can't save, cultivating these on the trees and then using those trees in forest agriculture on contour to retain soil. You can actually use those logs as retaining walls in forests, inoculate them with the mycelium of reishi mushrooms, and have kind of forest reishi mushroom plantations.
Right, a terraced.
That's right.
And just right behind that, we're going to have some ginseng golden seal. And we're going to be doing real good in our forest.
That's right.
So there's a goodness that can come out of everything, including the dying hemlocks.
This
is a
great example of how to reuse what we have. And for those who are in our area of Asheville, I would like those shiitake growers to go out into their woods and check out the logs, especially if you're about 1,200 to 1,500 feet above sea level. You're going to get a big flush right now, and this is the time. We got tomorrow is going to be warm, and before the winds come down from Canada, these mushrooms are a great source of all kinds of goodies for our body. Okay, so let's just mention some practical ways that people can learn more and play around with this kind of restoration. Zev? How do you feel about that?
I feel great about it. Really excited, in fact. And if there's any way I could put up a document at some point on the website for URTV or something, I can't put it up right now, but I have it on flashcard. I've written up a list of what I believe are the 25 most likely candidate species for myco-restoration in our area. So native fungi, and basically I've based that list on fungi that are bound to be relatively easy to cultivate, that have edible and medicinal value, and that are common enough that people are likely to recognize them and be able to identify them. And so these fungi cover a range of nutritive niches in ecosystems, which I'm not sure if we'll have time to get into, but there's this document that I can make available to people, and there's a myco lab starting up in West Asheville that will be able to provide mycelium in spring 2009 of
and we just had them on. The AB Tech Lab was on last week, and we encouraged everybody to start using this, but we also encouraged some public dollars that are out there to help the individuals come to the lab, because it is, for small people and small businesses, it's really tough.
I want to just say one thing too about how to use them, and one of the things is just getting them in your diet more, eating them, because the whole idea of stimulating the immune system, like Zev was talking about, they actually help the immune system fortify itself. And this maitake that is in the picture behind us right now, which Zev has been propagating here, and also shiitake and oyster mushrooms, and the reishi itself is not really edible. It can be made into medicinal tinctures. But just getting mushrooms into your diet on a daily basis is an excellent way. And I will say that it's really important to cook your mushrooms. Don't eat raw mushrooms.
That's for sure.
Yeah, I see salad bars all the time with raw mushrooms, but they're just going to go right through your body. They're no good. So always
it's good if you're on a
them.
diet,
Exactly.
Filler.
If you want to get any food from your food.
Yes, always cook your mushrooms.
Okay, so how can this, Zev, restoration be used as part of the contemporary forestry scene in North Carolina?
Well, that's a great question, because right now forestry practices, even logging companies who consider themselves to be sustainable loggers, basically are skipping a whole massive arm of the ecosystem cycle in our region. And what I mean by that is the fungi, because when you cut down trees and you take the trunks for timber, you're left with this huge amount of branches and stump material all over the ground, conventional practice is to burn the branches and sometimes dig the stumps out of the ground. What you could actually do is chip the branches into chips, mulch that land, even swale that land to catch the water and prevent runoff, inoculate the wood chip beds with certain species of edible and medicinal mushrooms, inoculate the stumps, which is what I'm doing right here in this picture, is inoculating a stump, a red oak stump with maitake mycelium, inoculate the stumps with mycelium from different species, and then plant tree seedlings with mycorrhizal fungal species attached to them, which are a beneficial symbiotic relationship between the tree and the fungi. And you'd basically jumpstart that forest, get the whole thing growing maybe 30 years ahead of schedule from what would happen if it was just left by itself. And you would actually bring the forest back more quickly for logging, and you'd also be generating edible and medicinal fungi during that 30-year interim while the trees got big.
Yeah, and let's not forget that this is not only for humans, it's for all of our relations that are out there that we need to start thinking about feeding.
And it does.
Yeah,
it does.
Animals love mushrooms, actually, especially slugs. I've noticed in my shiitake logs.
Okay.
Deer love certain. I've seen deer seem to love the pleurotus, the oyster mushrooms.
And there's some squirrels that rely entirely on truffles, native truffles, for their food source in the winter.
That's interesting. So that will be a way that we could become more aware by watching who's nibbling on what.
That's right.
So that we can help them in their survival too, which is really an important aspect. Now, we talked about the lab. Does propagating a fungi require a lab?
Well, no, but there are a couple of different ways you can go about it, which really could work well together. So basically, the purpose of a lab, in my view, is to allow us to propagate from really successful strains that we find out in the woods. If we find this huge reishi mushroom, this huge maitake, it's really healthy and doesn't have any parasites on it, we want to propagate that one, just like with plants. If you get a really good apple tree or something. So a lab is good for that because you can do some really simple, but they require sterility, lab techniques to clone the tissue. And this is cloning in a very non-GMO kind of way. It's a pretty benign thing. You're cloning that organism so you can then propagate it further. But then once you've gotten those strains going, Paul Stamets has developed and outlined in the book that Doris is showing, Mycelium Running, a number of very simple and effective techniques for what he calls low-tech propagation or non-sterile propagation, ways of allowing you to actually go out and propagate a huge amount of mycelium with totally non-sterile conditions and spread it throughout your forest in patches. And this is really empowering to me. It's like, just like digging up an elderberry plant and sticking it next to the creek or something. It's just very kind of easy to do thing, very accessible. And so I think the best kind of arrangement would be if we had some strategically placed labs that people could bring mushrooms to that they wanted to propagate. Those labs would provide the original mycelium, and then we'd all be able to take those to our homesteads and propagate them over the years, over time. That
is the key, that we have the knowledge and that we're able to use this knowledge to help bring about a better way. Plus the right livelihood that's attached to it as an important way for people to have a ability to make a living and still help the planet. So our call-in number, 505-2806. Please, if you're listening right now and you have a question, this would be a great time to give us a jingle, and we can then go ahead and answer your questions. Yes.
So one way I just wanted to mention of the propagate, it might be interesting for you to just mention one or two of those ways. But, I wanted to mention the oil that Paul Stamets began all this work. He was a tree, he worked with the Forest Service. And one of the things he developed is an oil for chainsaws that's got mycelium mushroom spores in it. So as you're cutting the trees right there, you're using that oil. So there's a really simple way.
Yeah.
And you can get that through his website, maybe other sources. Fungi Perfecti. We didn't talk about that, but he can be found all over the web.
Yeah. That's an opportunity. I remember when my logs were plugged with shiitakes, that we talked about the possibility of doing that, but we relied back on the old plug and drill and plug, I guess.
That's what I was thinking, maybe to explain just a little bit what that means for people who might not know.
Well, maybe I'll try to mention, how much time do we have?
We got time.
Okay, I'll mention maybe 4 methods. So they mentioned the drill and plug, which is one that does rely on sterile propagation. You make, basically it's these little wooden dowels, birch dowels, that are manufactured by the furniture industry, and you can inoculate those with mycelium from many different species of fungi. Then you simply drill holes in logs or stumps, pound the mycelium inoculated dowels into the holes, and cover the holes with wax or sometimes Vaseline and stuff like that to prevent insects from getting in and eating that delicious sweet mycelium.
Now we must mention that a mushroom, a fungi, is related to a tree or tree material, wood material.
Right.
And certain fungi, as we mentioned with the reishi and the hemlock, they have a relationship.
Very specific.
Right.
And also the shiitake with the oak.
Yeah.
So
and
you
oyster
don't
with poplar. Yeah.
oyster with poplar.
Right.
So you don't necessarily want to start plugging every tree that's out there.
Right.
You want to make sure that the trees that you are plugging are the correct trees.
Good point.
Okay.
Good point.
And the next
so that's all right. So that's kind of the most commercially centered one, because it's easy to do, but you have to buy the materials unless you have a lab to be making your own dowels. Then another one related to what Doris was talking about with the chainsaw oil that has spores in it is you can make what's called a spore slurry. And this is a non-sterile form. You basically make spore prints of a mushroom. You take a mushroom, put it on a flat pane of glass, the spores drop out and create this beautiful pattern which contains millions of spores. And then you brush those spores off into a jug of liquid with certain proportions of molasses and water in it. You let it sit overnight, and the molasses and water causes spores to germinate in that water, and then you basically pour that in the appropriate place for it to live in. According to your observations, like Robert is saying, of where you've seen that mushroom growing before, if it's associated with a certain tree or something. And then another method is mycelial propagation, non-sterile mycelial propagation. And what I mean by that, mushrooms love cardboard for some reason. It's just like worms, if you've noticed, with sheet mulching and stuff. They love cardboard, and you can take a piece of mycelium. If you dig up a little patch of mycelium from some kind of log, say from an oyster log, a tulip poplar log that has oyster mushrooms growing on it, you can gouge out some of that wood that has the mycelium on it. You'll see the little white strands of mycelium. You simply take that, put it in a yogurt container in between layers of moist cardboard, punch holes in the lid of the yogurt container to allow respiration, because mushrooms are like us, they breathe out carbon dioxide, breathe in oxygen. And the mycelium will actually start to colonize that moist cardboard. You need to keep it moist for a couple of weeks. Finally, when those little patches of cardboard become colonized with this thick, ropey, white strands of mycelium, you take those out and put them between big sheets of wet cardboard. The mycelium will spread to those sheets, and then you can take those big sheets and spread them out and put wood chips over them, and boom, you've got a mushroom patch. And that's all done totally non-sterile, and it's an exponential expansion of mycelium in that way. The last method that I'll mention is for propagating mycorrhizal species of mushrooms. Maybe we'll have a chance to get into that, the difference between mycorrhizal and saprobic mushrooms in a second. But mycorrhizal mushrooms, truffles, are an example of them. The extremely expensive Perigord black truffles and Italian white truffles that grow in Western Europe. It's just a fungus that has a mutualistic association with a certain species of tree, sometimes a couple of species of tree. The way that they've propagated them, the truffles in Western Europe for hundreds of years, is say that you have a hazelnut or an oak that you know truffles grow on every year. You know that the truffle fungus is inhabiting the roots of that tree. They simply would take seeds they take acorns or hazelnuts and plant them in a big patch around the known tree. And those trees, when they sprouted and grew, would become inhabited by the symbiotic fungus. Then they'd simply transplant those trees out. And there's an 80% success rate for that method.
That's a great one.
So if you know of mycorrhizal trees, like chanterelles are mycorrhizal.
Right.
Morels, there's some debate on whether morels are mycorrhizal. There are perhaps native species of truffles. There's some russulas are really prized, and lactarius, really prized mycorrhizal mushrooms around here. And you know that they're growing near a certain tree, propagate that tree with seed right around there and try that method.
Gotcha.
Yeah.
That's a good one.
Yeah.
Well, there's lots of ways for people to get involved, and definitely lots of ways to be experimenting. We would like to hope that some of the schools and the teachers might be listening. This would be a great project, inexpensive, and the kids would see this stuff coming up and not believe it, that they could grow this mushroom at right in their classroom or outside in the window, somewhere close by. So I think that we have a lot of work to do in this area, but